In this problem, we're asked to evaluate a limit. This is a limit of a rational function, so it's got division involved. And typically, what I will do on these is gather a little clue here. Ask myself what happens as x gets very close to the value in both the numerator and denominator. Now, I put this in quotes because these values here are not going to give me the value to the limit of the limit typically, but they will give me a clue as to how to proceed. And if you notice, in the numerator I get a 0, and in the denominator, if you push through the arithmetic, we also get a 0. And this is a very valuable clue then. This says to me that there is a 0 in the numerator and denominator at x equal 3. So in this case, it'll tell me to factor and cancel. Once I cancel those, I have a possibility of evaluating the limit. But I cannot tell you if the limit exists or not right now. This is just gives me a clue as to what algebra to do. And it actually gives me more than that. Since the 3 is causing the 0, there must be a factor of x minus 3 in both the numerator and denominator. So this denominator must factor into an x minus 3 times something. Numerator has an x minus 3 in it, nothing else. But what I learn here is that it helps me factor. I need a plus 6 here, I've got a minus 3, so this must be a minus 2. And you can check to see that the rest of it works out. Once you've factored, then we just cancel the factors. Once the cancellation has occurred, once we've eliminated our problem spot that we spotted with our clue, I can now talk about the limit again. So I'll write the cleaned up version here, and we see that in the numerator, as x goes to 3, I have a 1. In the denominator, as x goes to 3, I have a 3 minus 2, which is not the number 0. So I'm done. That's the limit. Again, the interpretation of what that's telling us in terms of the graph is a good idea to think about. What we've just discovered is that at x equals 3, there is no y value. There is no y value because division by 0 occurs at x equal 3. So 3 is not in the domain. But we have found out that the graph approaches the height 1 both from the left and